Welcome to Astronomy Daily, your source for the latest space and astronomy news. I'm your host, Anna, and today we've got an exciting lineup of stories spanning from groundbreaking NASA launches to mysterious signals from space, and a reminder about a spectacular upcoming lunar eclipse. We'll be diving deep into some fascinating developments that showcase just how dynamic our understanding of the cosmos continues to be. So let's get started with today's news. Let's kick things off with a launch that could have a lot of people saying, "at last." NASA has just achieved another milestone with a remarkable 2-for-1 launch that sent both the SphereX Telescope and the Punch mission into orbit aboard a SpaceX Falcon 9 rocket. This joint launch from Vandenberg Space Force Base represents a smart way to maximize science while minimizing costs. SphereX, which stands for Spectrophotometer for the History of the Universe, Epoch of Reionization and ICE's Explorer, will spend the next 2 years creating the most detailed map of our universe ever attempted. It will survey more than 450 million galaxies and over 100 million stars in our own galaxy, all while looking at the sky in 102 different colors of infrared light. What makes this telescope truly special is its ability to search for the basic ingredients of life throughout the Milky Way. It will peer into molecular clouds where new stars and planets are forming, looking specifically for water ice and other organic molecules that could help us understand how life might emerge elsewhere in the universe. Meanwhile, the Punch mission, consisting of 4 small satellites working in perfect synchronization, will give us an unprecedented view of our sun's outer atmosphere and the solar wind. Think of it as a cosmic weather station, helping us better understand and potentially predict space weather that can affect everything from our power grids to our satellite communications. Together, these missions showcase NASA's ability to study both the very large and the relatively close to home. While SphereX looks out toward the farthest reaches of space, Punch will keep a watchful eye on our own stellar neighbor, helping us better understand the complex relationship between the Sun and Earth. This launch marks an exciting new chapter in space exploration, promising to fill in crucial gaps in our understanding of both our cosmic origins and our daily interaction with our home star. The data from these missions will not only help answer long-standing questions about the universe, but will likely raise fascinating new ones as well. Next up today. In a fascinating turn of events, new research has cast significant doubt on what was previously thought to be evidence of an interstellar visitor. The story revolves around a meteor that blazed through Earth's atmosphere back in 2014, creating quite a stir in the scientific community when researchers claimed to have recovered fragments of it from the Pacific Ocean in 2023. Initially, the discovery seemed groundbreaking. Harvard scientists, led by physicist Avi Loeb, had used what they believed were seismic signals to pinpoint the meteor's location, and subsequently recovered hundreds of tiny metallic spheres from the ocean floor. These spherules showed unusual concentrations of elements like beryllium, lanthanum, and uranium, leading to bold claims about their potential extraterrestrial, or even artificial, origin. However, a new international research team, led by scientists from Johns Hopkins University, has revealed a rather mundane explanation for the seismic signals that guided the original search. What was thought to be the signature of an interstellar object entering our atmosphere was actually just the rumbling of a truck driving past the seismic monitoring station on Manus Island. The researchers found that the signal's characteristics perfectly matched those of a vehicle moving along a nearby road and bore none of the telltale signs they would expect from a meteor impact. Even more significantly, their analysis suggests the actual meteor entered the atmosphere more than 160 kilometers away from where the original team conducted their search. This revelation raises serious questions about the nature of the recovered spherules. While they may still be of meteoritic origin, they're likely either from a conventional meteor or perhaps represent a hybrid of cosmic and terrestrial materials created when a meteorite impacted Earth's surface. What's clear is that they're probably not the remnants of an alien spacecraft or interstellar visitor that some had hoped they might be. This case serves as a perfect example of how science constantly refines itself through careful review and new analysis, even if it means replacing an exciting possibility with a more prosaic explanation. Exciting news has emerged from the world of exoplanet research as scientists have finally confirmed the presence of not just one, but four small planets orbiting Barnard star, our cosmic next-door neighbor after the Alpha Centauri system. Located just 6 light-years away, this discovery marks the end of a decades-long quest that has seen numerous false starts and unconfirmed claims. Using the specialized Maroon X instrument, designed specifically for observing M-dwarf stars like Barnard star, researchers conducted detailed observations from 2021 to 2023. The team had to carefully separate the planetary signals from the natural variations caused by the star's own activity cycles and rotation, but their persistence paid off with the confirmation of 4 distinct worlds. These newly confirmed planets are truly remarkable, with masses ranging between just 19% and 34% of Earth's mass. In fact, one of them might be the smallest planet ever detected using the radial velocity method. What's particularly fascinating is how tightly packed these worlds are, all orbiting their star in periods between 2.34 and 6.74 days. The discovery raises some intriguing questions about the system's stability. While computer models suggest the planets could maintain stable orbits if they're perfectly circular, the best current measurements indicate that any slight deviations could make the entire system unstable within just 2,000 years. This presents an exciting puzzle for astronomers to unravel. For those wondering about the possibility of life, these planets unfortunately orbit too close to their star to be in the habitable zone. However, the research team hasn't ruled out the existence of additional Earth-sized planets in more life-friendly orbits. They've just confirmed that if such planets exist, they must be smaller than about half of Earth's mass. This breakthrough comes after more than half a century of searching, during which various teams have claimed to find planets around Barnard's star, only to have their discoveries later disproven. This time, with multiple independent observations and careful analysis, we can finally say with confidence that this ancient star, estimated to be about 10 billion years old, is indeed home to a family of planets. Let's move on to an update from the Moon. The Athena moon landing mission, while achieving the remarkable feat of reaching the lunar surface, encountered an unexpected challenge, shall we say, that has impacted its objectives. The spacecraft, operated by intuitive machines, successfully touched down near the lunar South Pole on March 6th, but ended up in a sideways position that severely limited its capabilities. This orientation proved particularly problematic for the mission's power generation, as the solar arrays couldn't properly capture sunlight in their tilted position. As a result, the mission's active phase lasted only about a day after touchdown, though it did manage to beam back valuable images from the lunar surface during this brief window. One of the most affected components was the Mobile Autonomous Prospecting Platform, or MAP rover, a compact four-wheeled vehicle that was poised to make history with its own lunar exploration objectives. The team behind MAP has confirmed that their rover survived the landing intact and was fully operational, but the lander's sideways position made deployment impossible. It just couldn't get out. Despite these setbacks, the mission wasn't without its silver linings. The MAP rover successfully collected valuable data during the journey to the Moon, while in lunar orbit, and even after landing. These measurements have validated numerous systems and components that will prove invaluable for future missions, including planned expeditions to the Reiner Gamma region and additional ventures to the lunar South Pole. This experience has provided crucial insights that will inform upcoming lunar missions, with intuitive machines already planning their 3rd launch for later this year. The space exploration community continues to demonstrate that even when missions don't go exactly as planned, the knowledge gained helps pave the way for future successes in our ongoing exploration of Earth's closest celestial neighbor. Seems everyone's getting into the citizen science projects at the moment. The European Space Agency has just launched an exciting new initiative that opens the door for space enthusiasts to directly contribute to solar research. Their Solar Orbiter spacecraft, which has been observing our star since 2020, has amassed an impressive 5 years of data that needs expert analysis, and they're turning to citizen scientists for help. The project, called the Solar Radio Burst Tracker, focuses on analyzing radio waves emitted by the sun. Every day, our star releases powerful bursts of radio waves into space, which are detected by the spacecraft's radio and plasma waves instrument. With over 15,000 radio wave graphs to examine, it's a task too massive for individual scientists to tackle alone. What makes this project particularly fascinating is that these radio bursts, known as Type 3 solar radio bursts, are closely connected to solar flares, those massive explosions of radiation from the sun's surface. When these flares occur, they shoot electrons into space, which then interact with charged particles around the sun to produce distinctive radio wave patterns. The timing of this project couldn't be better, as 2025 marks a peak in the sun's 11-year activity cycle. We've already seen evidence of this increased solar activity through spectacular aurora displays visible across Europe. By tracking these radio bursts, citizen scientists will help create the first comprehensive catalog of solar radio bursts observed by Solar Orbiter. Participants don't need any specialized knowledge or equipment. The project provides detailed guidance on how to identify and outline radio bursts in the data. Each graph will be reviewed by multiple people to ensure accuracy, and the resulting database will help scientists better understand solar behavior and its potential effects on Earth. This initiative represents a unique opportunity for the public to contribute to cutting-edge space research, while also helping to train artificial intelligence systems that will automate this process in the future. It's a perfect example of how modern space exploration is becoming increasingly collaborative, bridging the gap between professional scientists and passionate space enthusiasts. If you'd like to find out more, I'll include a link in the show notes. Before I go today, a quick reminder. Mark your calendars for an extraordinary celestial display coming up on the night of March 13th into the early hours of March 14th. The moon will undergo a dramatic transformation as it passes through Earth's shadow in the first total lunar eclipse we've seen since November 2022. During this spectacular event, our lunar companion will take on an eerie reddish glow, creating what's commonly known as a blood moon. This stunning color change occurs when Earth's atmosphere filters sunlight, allowing only red and orange wavelengths to reach the lunar surface, the same effect that gives us vibrant sunsets here on Earth. The eclipse will unfold in several phases, starting with a subtle dimming as the moon enters Earth's outer shadow, or penumbra, at 8:57 p.m. Pacific Time. Things get more dramatic around 10:09 p.m. when the partial eclipse begins, and it will appear as if a giant bite is being taken out of the moon. The main event, totality, kicks off at 11:26 p.m. Pacific Time, when the entire moon will be immersed in Earth's shadow and take on its characteristic red coloring. What makes this event particularly special is that you don't need any fancy equipment to enjoy it. While binoculars or a telescope will enhance the view, the eclipse is perfectly visible to the naked eye. The show will be visible across the Western Hemisphere, offering excellent viewing opportunities for many observers. As an added bonus, skywatchers can also spot Jupiter and Mars in the western sky during the eclipse. The darkened moon will actually make it easier to spot stars and constellations, with our celestial companion positioned in the constellation Leo at the start of the eclipse before crossing into Virgo. The total phase of the eclipse will last for about an hour, ending at 12:31 a.m. Pacific Time on March 14th. The moon will then gradually emerge from Earth's shadow, with the entire event concluding around 3 a.m. Pacific Time. Weather permitting, this promises to be one of the most impressive astronomical events of 2025. And that's it for today. Thanks for joining me on Astronomy Daily. I'm Anna, and I hope you've enjoyed this journey through the latest developments in space science and astronomy. If you'd like to explore more cosmic content, head over to astronomydaily.io, where you can find all our previous episodes. And don't forget to join our growing community across social media. You can find us as Astro Daily Pod on Facebook, X, YouTube Music, TikTok, and check out our brand new Instagram account. Keep looking up, and I'll see you again tomorrow among the stars.